Okay, we're going to carry on from even the previous lessons. So let me zoom in a little bit. They want to know all the possible values that could make this true. Okay? So, do you remember when we did, I know we've done a lot. Where are we? We've done a lot, haven't we? Oh yeah, we did this page right here. Let me zoom it out. Remember when we did this page and sometimes they would give us the right answer in the right quadrant and sometimes they wouldn't? And that's because sometimes things are positive here and negative here. And what I want you to see is if you look at the unit circle, if you see how negative rad 3 over 2, see how it's also over here? And then if you have positive rad 3 over 2, it's also over here. And see how you have, so that means those answers are positive, but these answers are negative. So I might say, okay, how many different quadrants could you get a positive answer? How many different quadrants can you get a negative answer? That's kind of what you're focused on. And so if we look here, I drew this little thing for you. And of course, some of you will memorize it, but I'm not a big memorizer. Right, down, left, up, left, left, where the first number represents cosine and the second number represents sine. So they want to know in which quadrants will cosine be positive. Well, if this is quadrant 4, 3, 2, and 1, I know that it will be positive in quadrant 1 and quadrant 4. Okay? So I know that. Now, if I know that and I see a rad 3, I know that I'm thinking of a 30, 60, 90. So now they want you to find the exact values. So if I was to use the unit circle, I can see the exact values that make it positive are at 30 degrees and 330 degrees. But I don't have the unit circle to memorize. I actually need to do this problem myself. So if I was to graph this and I have a triangle in quadrant 1 and a triangle in quadrant 4, I know when I'm dealing with cosine and I'm looking at my thetas, it's this right here. That value right there represents my adjacent. So that means that this is my rad 3. That means this is my 1 and that's my 2. So, who's across from the 1? Oh, 30 degrees. That's my answer for quadrant 1. Well, if this also represents 30 degrees, and this line represents 360, how many degrees is this really? 330, because this minus this gives you that. So the two answers are 30 and 330 degrees. Now some of you go, well, how'd you know it wasn't in this quadrant and this quadrant? Well, if I drew triangles in all quadrants, okay? And I know it's not pretty, but whatever. And I'm dealing with cosine. Cosine means adjacent over hypotenuse. And if my theta is always there, my adjacent is always here. Well, when I go to the left, that's negative. So that means there aren't any triangles that are going to work over here. Okay? Now let's go over here. If we're going to play this game, where is sine positive? Well, sine is positive in the first quadrant and the second quadrant. And if I'm dealing with a rad 2, it's a 45, 45, 90. So now I'm going to draw it here and here. Now some of you go, how did you know that it was going to actually be that if you didn't have this cute little picture? Well, sine is opposite over hypotenuse. Sine is opposite over hypotenuse. When we go to the left, it's negative, but when we go up, it's positive. And that means this is a 45, 1, 1, rad 2, 1, 1, rad 2. So if this is 45, oh, in quadrant 1, 45. But if this one, how am I going to figure out that one? Okay, well, this is 180, and that's 45, so 180 minus 45, 135 degrees. All right, let's go to the next one. Tan. Well, tan is sine over cosine, so let me look. And it's got to be positive, so let's look. A positive divided by a positive is a positive, quadrant 1. and quadrant. No, that's a negative. Oh, a negative and a negative make a positive. Quadrant 3. So now I'm going to draw my 2 triangles. Just got to pause it real quick. Hold on. And I know tan is opposite over adjacent. And it's a rad 3. Oh, so it's a 30, 60, 90. So I can't put rad 3 and 3. That doesn't look familiar. But I know that that happens when there is a radical in the denominator. If I have 1 over rad 3, rad 3, rad 3, rad 3 over 3. So I know it's really 1 over rad 3, which means this is opposite and this is adjacent. So this is opposite and this is adjacent. This is opposite, this is adjacent. Who's across from the 1? 30 degrees. Oh, I like quadrant 1, 30 degrees. Now, if this is 30 degrees, what's this going to be? Well, if this is 180, 180 plus 30, 210. Let's do the next one. Cosine is negative in the second and third quadrant. If it's a rad 2, it's a 45, 45, 90. Draw here, draw here. If it's negative rad 2 over 2, it's really negative 1 over rad 2. Rad 2, rad 2. Cosine is adjacent over hypotenuse. Okay. But that doesn't really matter because what you really need is the degree. But that's just throwing that out there. So that's 45 and this is 180. So I'm going to subtract from 180, 135. And I add to 180, 225. And can you always check using the unit circle? Of course, but I want you to show your work as if you're not using the unit circle. All right. Tan. All right. Tan of negative 1. So tan is sine over cosine, which means that's going to be 1 over negative 1. Oh, okay. So that means it's a 45, 45, 9. Oh, tan. So where is tan negative? Tan is negative in the second quadrant because this divided by this is negative. This divided by this is negative. That's positive when you divide. So it's here and here. Sorry, you can't see that. Now, if we're dealing with negative 1 and 1, it's a 45, 45, 90. What do? Subtract 135. And then what is it closest to? 360. So 315. Okay. I want to do one more. Cosine. All right. Cosine is 1. If it's 1, then that's when you're doing 1, 0. 1, 0. 0 degrees, 360. Let's pretend that said sine. If it said sine, it's 0, 1. 90 degrees. What if instead it said inverse sine of negative 1? Well, let's see. Negative 1 is my second number, 0. 0, negative 1 is here, and that's 270 degrees. I'll be going over this in Zooms, of course.